There's also a pattern when we have a sum or difference of binomials. And what we mean by that is just like what you see here in these examples. It appears to be the same terms in the binomials. It's just that with one of the binomials, we have a sum, and with the other binomial, we have a difference. Before we start looking at the patterns or what the shortcuts may be, let's go ahead and multiply these binomials and see if we can find for ourselves what that pattern might be. For the first binomial pair here, I am going to use the area model to multiply. So I have a plus 8 being multiplied with a minus 8. A times a is a squared. A times negative 8 is negative 8a. 8 times a is positive 8a. 8 times negative 8 is negative 64. And I see that we do have like terms. And I also see that these like terms are opposites, so they're actually going to cancel each other out. So my answer ends up being another binomial, but this time it is a squared term for my leading term, a squared minus 64. For the second binomial pair, I will go ahead and use the distributive property or FOIL. 4x times 4x is 16x squared. 4x times negative y is negative 4xy. Y times 4x is positive 4xy. And positive y times negative y is negative y squared. Taking a look, I see that I do have like terms. These terms both have xy, but again, these are opposites. One is negative 4, one is positive 4, so they will cancel each other out, and once again, my result is another binomial. The leading term has a degree of 2 minus y squared. 16x squared minus y squared. So take a look at these. Do you see a pattern? How would you describe it? Go ahead, pause the video, take some time and look at what you see. Hopefully what you saw was that the first term is squared, the second term is squared, and we end up with a subtraction. And that's because when I take the last term times the last term, a positive times a negative is going to be a negative. But as we saw in our previous problems, the middle terms always canceled out. So when you have two binomials, one a sum, one a difference, and the two terms inside are the same, we call that a sum and difference. We can just square or multiply the first two, or the first terms, and multiply the last terms and put a subtraction. So when I have x plus 3 times x minus 3, all I need to do is x squared, that's the first term, subtract the 3 squared, and simplify x squared minus 9. So for example, we have x plus 10 times x minus 10. So that becomes x squared minus 10 squared, which simplifies to x squared minus 100. For number 6, we have 2x is the first term, so make sure you square 2x, and then minus 1 squared. So 2x times 2x is 4x squared minus 1. And for our last example, square the x minus, the last term is 3y, so we square 3y. And we have x squared minus 3y times 3y becomes 9y squared. This is a nice little shortcut to use when we have this pattern. Again, you don't have to memorize this pattern. It's just very useful. You can always use the area model to multiply, or you can use the distributive property.